The time is 7 o'clock.
Thank you very much. Good morning, everybody. Okay, first of all, an alert. I just saw this. There will be hamburgers and hot dogs today at noon in front of the department. It's free. So if you are having lunch, you better go there and you get yourself a free lunch today. Don't forget, at noon in front of the department. I just read the hat. Okay, good. Enough of this. So let's continue our discussion from last time. We started looking into casting, and we said multicasting is the process of delivering of a pack or more senders to a group of receivers. In other words, multicasting could be one to many or many to many. So it's multicasting. It could be one to many to multiple receivers or multiple senders to multiple receivers, depending on what. So, for example, in some applications where you require, for example, a teleconferencing or a video conferencing, we do many. They exchange informations among themselves. If you are playing games, for example, interactive game over the internet with a group of people or group of friends, this is also many to many. If you are sending, example, network news, sports, weather, stock tickers, and so on and so forth, this is what? One to many. A service, some provider providing all of these services to most. If you are sending software upgrades, you want to upgrade your software in branches of your headquarters, for example, well, what will multicast that update to all of these? Are multiple applications that are more suitable to be done through the use of multicasting. We discussed the difference between multicasting and multiple unicasting. In multiple unicasting, let's assume these are the receivers and this is the sender, the source. The source is going to make how many? Is going to make, so these are interested in receiving messages. It's the same message, the same. The source is going to make the what? Three copies. By the way, these, each one of them is a what? Is a what? A unicast. Each is a unicast packet. The message is identical, but the header is not identical. Header is addressed to a specific player. So he makes the three copies here. The router will make what? Will forward two of them here. Will here. This one will forward one of them here. This one will forward one, it will forward these to each one of these individual packets. 1, 2, 3, 4, 5, 6, 7. So we have what? 9 packets. 9 packets. Whereas in this case here, what? Does not make copies of the packet. It's the same packet. This is the same packet. It's addressed to what? Addressed to the group. We will see how that is done in just a second. Address group, this one here, the router will make what? Will make copies. Let me ask you a question. If there is no interest in here, will this router make a copy of the packet to this link? He will not make a copy of the packet to know what? If there are no receivers in here interested in receiving this packet. So the router will be as a per needed basis. In this case here, he made a copy here and he made a copy here. Those two packets are identical. And the message, both the header and the message, these are identical packets. This one will forward a piece of this. I send it to here, send it to here. This one, he will make only one copy. He will only forward that copy here for a total of how many? 1, 2, 3, 4, 5, 6. We have 6 packets. What? This is more what? More bandwidth efficient. Instead of sending 9 packets, you are sending what? You are sending only 6. Another advantage of this over this, you notice in here is that the sender multiple copies of the packet. So if the sender has a what? If the sender has a relatively slow link, this one will behave as a what? As a bottleneck. Whereas in here, the copies are in the network rather than at what? At the source. And the network has much more resources than each individual. Did you understand this difference between this one and this one? Did you get it or not? In here, all of it, it's like there is a concentration of the traffic at the source itself. Whereas in here, it is distributed across. Clear? Oh, so this one is more efficient to this one in terms of the bandwidth efficiency and in terms of what? In terms of prevention of bottlenecks at different centers. Okay. Now, what are the issues that we cannot go into details into each one of them, but we will survey them just to get an idea of how do you identify the multicast receivers? In other words, how do these routers, when we say that copy in here and make a copy in here, how do this router know that there is a what? There is an interested receiver, there is a here who is interested in receiving this multicast? No. Somehow that router needs to have a knowledge that there is a receiver in here who is interested in that multicast group. How do you address the packet to send to those receivers? A moment ago, that these packets are what? Are identical. So there must be some kind of what? Special at the group rather than to what? Each individual host. Rather than each individual host. So how do we address these receivers? How does a multicast group get started? How do you start your multicast group? You start your multicast group, what do you need to do? All of these questions, we will see them in just a second. Can you join it started already? So there is a multicast starting already. Can you join in the middle? Because you decided to what? To leave the multicast. Can you leave the multicast at any time you want? Maybe the multicast was what? You follow me or not? And you want to leave the group. Can you do that at any time? So we need to see how does how they are added, how they are deleted from a multicast group, and so. Do group members need to know other group members? In other words, this one here, for example, does this one here needs to what? Needs of these group members. Sometimes what? Sometimes he doesn't need to know. The multicast, whoever is interested in receiving the multicast, it can join the tree or can join the group. Might not be interested in knowing every one of them. This one might not be even a member of the group itself. What does that mean? When I say the source is not a member, what does that mean? It means the source is sending the packets to the group, but he is not willing packets from the group. He is not willing to receive packets from the group. He just wants to send group, not receiving from it. So he's not part of the group. Clear? Okay, we'll see all of these issues as we move along. These routers interoperate with each other. How do they know that they're, for example, in here again, in one know that this one is interested. Somehow this one needs to tell it. This one needs to tell it that there is a host in here who is interested in joining the multicast group. Clear? So how do they act? In exactly the same way as in unicast routing. In unicast routing, those routers, do they among themselves? They do exchange information, routing informations among themselves. In here, what do they exchange? Multicast informations about themselves. So the routers, they all need to be what? Multicast ready. They need to have these protocols implemented in them. Clear? Not every router can what support multicast. See shortly. How do the routers interoperate to deliver multicast packets? There are many others. We cannot discuss them in detail in this. Give you an overview of them. More in-depth discussion, you might study it in CS 551. Anybody? Nobody's taking this class? Nobody? Okay, anyway, maybe in the class, CS 551, there will be more discussion about multicasting. Now, let's see the difference, again, as I told you, the difference between unicast and the multicast. Let's assume this router is attached to this networks, N1 and N2 and N3. What is he going to add to the internet? He is going to advertise, this is a unicast. He is going to advertise to the rest of the internet. He is going to tell them, I am connected to what? N1 and N2 and N3. Advertisement in the unicast routing. In the unicast routing, this one is going to advertise to the rest of the internet, I'm connected to N1 and N2 and N3. The multicast, what is he going to advertise to the rest? He is going to advertise the following information. I have interest, which are somewhat. There are some hosts in the networks that I am attached to who are interested in multicast groups, G1 and G2 and G3. Clear? Okay, by the way, question. Interested in more than one group? Could a host be interested in more than one group? So for example, here, this one, there's an interest to what? In G1 and in what? G2 groups. Two different groups. He might be interested, there might be hosts interested in multiple of them. Here, multiple of them. Internet know what? When the routers in here, in the internet, know that this one, there is an interest in here. Whenever they receive a packet destined to say V1, will they make a copy and send it to this? They will make a copy and send it to this router. Did you follow me on that? The router already told them that I have host on my networks that is in this multicast group. Now, when he receives the copy, will he send it to this one? No, he will not send it to this one. There's no interest in here in what? In G1. Will he make a copy to this one? He will make a copy to this one, and he will make a copy. In other words, in the routing tables, in the multicast routing table, he will have a database or a table that tells it what? Which link there's an interest in receiving which group. So far. Clear so far? Okay, good. Now, we'll get to all of these issues in just a second. Now, let's start for addressing, the multicast addressing. Now, if you remember, which is doubtful, if you remember from, we have what? We have classes A, B, C, D. This D is the what? Is the multicast class. Do you still remember this or not? You don't. Okay, class D is for multicast addressing. Okay, consists of the following. This is how many bits long? This is 32 bits long. Is the IP address. The first 4 digits are what? 11. And here we do have the what? The multicast address. Multicast address. How many multicast addresses do we have? How many do we have? The number of multicast addresses is 2 to the what? 2 to 28. Did you answer where the 28 came from? The 28 because there are what? 24, sorry, 20 here. These are the multicast addresses. Some of them are reserved for some special purposes, but this is how many addresses do we have? Okay, how do you know that this address is a multicast address? By looking at it with what? 2, what is 1111? So it starts with what? 110000, and then the second digit, third digit, all the way to what? 111111, third digit, second digit, third digit, fourth digit. What is it? Sorry, in decimal. I said in binary. What is this in decimal? You are, how many digits? 32 bits is divided into what? 4 bytes. This is 1 byte, 1 byte, 1 byte, 1 byte. This one starts from what? 1111, fixed. Digits are what? 0000, all the way to what? 1111. What is in decimal? In decimal, what is it? 224 to what? 239. Did you get this or not? Okay, which means what? No, I made a mistake. 1 second. It's 220 what? No, this one does not go to 111. No, this one does not go to 1111. 11155. Sorry, this one goes to where? help me. This one is 224. To this one here, 239, which means what? Did I mess up? This one is. This one is 224? Okay, 239, it means what? It means I'm adding what? One? Say that again? Oh, 0, 111 like this? Why? No, but if this is 224, this one is not 224. Sorry, this one is 1110. I'm sorry, 1110. My mistake. 1110. Now it's okay. This one is what? Like this. Sorry, the first 4 digits is what? Is 1110. Not 1111. 1110. How much is this now? 224. Yeah, because it's what? It's 128 plus 64 plus what? 32. Yes? 224. And this one is what? 224 plus what? 50. 239. So, again, you can tell a multicast group if the first byte, which is the most significant one, starts from 224 to what? To 239. Anywhere between 224 to 239. Insider notation, by the way. Inside. Again, CIDR stands for what? The classless the block, the multicast block. Is 224.0.0 slash anybody? Anybody? 4. Why 4? Why 4? Because the only what? Only digits that what? It's a 4 digits. The rest is what? It's part of the address. Clear? The rest is a part of the address. How big is this block? Big is this block? What is the size of the block? The size of the block inside is what? 2 to the what? So what? N. What is the N in this case? 4. So it's what? That's what I just told you. 28. Clear? Okay. Now, one side note here. So that you understand the, I don't want to get into too much detail, but I understand that. Ethernet, which is what? Layer. Second layer, protocol, support, multicasting. I need you to listen to me. We are talking about what? What is the title of the chart? Is the title of the chart IP multicast? Clear? IP multicast, which means which layer are we talking about? Are we talking about? We are talking about layer 3. We are talking about the packets. Yes? So that will have this format here. This is the what? 1110, always 1110. And this is the multicast group address. Yes? Where am I going to put this packet? I'm going to put this packet. I'm going to put the packet in a what? In an Ethernet frame. I'm going to encapsulate it in an Ethernet frame. What do I put in the destination MAC address? Remember, in the header of the frame, what do I need? In the header of the frame, what do I need? The source MAC address and the what? Destination MAC address. What am I going to put in the destination MAC address? You are losing me here. Okay, this is the IP multicast packet. This is the header, and this is the what? The payload. In the header, what do I see? Multicast packet. What do I see in the header? I see the source IP address and destination IP address. The source IP address is the IP address of the sender. The destination IP address is the group, is the multicast group. Yes? I am going to put this one in a what? What is this? What am I? That's the Ethernet what? Clear? In other words, this is what I'm talking about. A router, and this is A, and this is B. And both of them are entering what? G1, G1. Both of them are interested in receiving multicast group G1. Yes, the router receives a what? A packet addressed to what? To G1, to that group. What does he do? By the way, does he send onto this one, or because they are connected to the same Ethernet, he only send one copy and they are going to receive it? Same one, because they are connected to the same network. What does he do? What does the router do? He puts it in a frame. Yes? What is this? What? This is the header of the frame. What is the source MAC address? Source MAC address. Oh, you are struggling badly here today. What is the source MAC address? You are not getting this. Jeez. Okay, the router. The MAC, source MAC address. It's what? R, destination MAC address, an Ethernet MAC address is an Ethernet address. Ethernet multi, I cannot spend too much time on this, so if you are not getting it, read on your own. Ethernet multicast address consists of the first 23 bits, the multicast IP multicast address, which means what? Which is a 28 address. It's a 28 bits. First what? The first 23 bits. The first one are mapped into what? Into the Ethernet multicast address. And the remaining 5 bits, these 5 bits are ignored. And what does that imply? That implies that there are 2 to the multicast group addresses that will map to the same Ethernet multicast address. You feel good if you are not following me here. Does not make me feel good at all. Okay. Can we, let me try it again, see if you can get it this time. This is a packet. This is a packet. What do you see in the header of the packet? You see the IP addresses. Yes? This packet is a multicast packet. So this router receives this multicast packet from somewhere else. There are group members in here interested in it receiving this multicast packet. He needs to put the packet in a what? In a frame. The data link layer comes what? Below the network layer. So when he puts it in a frame, the frame is called what? An Ethernet frame. In the header of the you see the source MAC address and the what address. The source MAC address is what? Is the MAC address of R. Agree? What is he going to put in the destination? In the destination MAC address, he needs also to have a what? A multicast Ethernet address. A multicast Ethernet address. In other words, needs to be defined both in the link level or in the what? In the network IP, in the packet level, and in the what? In the frame level. Clear? Clear? Ethernet, 23 bits are used for what? For multicast. Let's see if you remember. How many bits in the MAC layer, in the MAC address? In the MAC we have. How many bits do we address? Oh no, it doesn't work this way. I need to move on. Recall MAC address is 48 bits long, which means what? 6 bytes. Okay. 54 bits represent the vendor of 24 bits represent the address of the card. Multicasting, they use what? They use this is a 0, and this one here is 23 bits. Left for what? So the mapping, and these 23 bits are these 23 bits in the what? In the IP multicast address. You map the first 23 bits in the multicast, in the IP multicast address to the what? To the in the MAC multicast address. Okay, so there might be what? 2 to the 5th multicast group addresses that will be mapped to the same Ethernet multicast. These 5 bits are what? Are ignored. Clear? Okay, which means what, by the way? It means may receive packet is may receive a multicast packet that belongs to a different group. To a different group, which means what? The network layer in that host will recognize that and will drop it. Clear? Okay, let's move on. I cannot dwell on this. Your background is not up to the task. Let's continue with our discussion. Okay, so we have the multicast block is what? 224.0.0.0 slash what? 4. So for example, in this case, these devices will configure their what? Their interfaces to receive that multicast. In this case, what is the multicast address? It's 226.14.18.7. 226, 14, 18, 7, 226, 14, 18, 7. All of them are what? Interested in that multicast address. And you can see also in association with that, they also have their own what? This is what? This is their unicast address. To the what? In addition to the multicast address, they also have their own what address? This is a unicast address, 14.22.45.3. This is the clear? So this is the address. Now, let's get into the other issues involved with multicasting. How do hosts join or leave the group at any time? And a host, again, as I told you, can be a member of multicast groups. A host can be members of multiple multicast groups. The senders, members of the group. Again, when I say the senders need not be members of the group, it means what? The sender is only send the packet to the group, but he is not willing to what? He is not willing. This means what? Senders are not willing to receive from members. They are not willing to receive from a group members. They just sent it. Multicast group members do not know about each other at the network level. Other at the application level, they might know each other at the application level, but at the network level, they don't need to know about each other. Clear? Because you are not what? You are, by the way, do you know to which network are the multicast receivers? Where are the multicast group receivers located? On which network? When we saw the address, do you see an address of a network? Do you see an address of a network here? Address of a network. This is just the prefix, 1110. There is no address here. No address or network. It means that the receiver, the multicast group members do not know about each other from what? No address, again, no address. No network address. Now, these are the questions that the three components of IP multicast. The first one, which we already discussed, is a multicast group addressing. We already talked about this. How to join or how to leave a multicast group. This is through a protocol called what? Internet Group Membership, or they call it what? IGMP. IGMP, right to you in just a second. The Internet Group Membership Protocol, IGMP. And the third one is what? How we implement the trees, the multicast, what is known as a multicast routing tree, through the using protocols. We will discuss several protocols here for multicast routing. Clear? Now, let's look at the IGMP first of all. Let's look at the IGMP. IGMP, first of all, is a what? Is a local protocol. Have we seen before another protocol which is local? What is a local? Local protocols. Local protocol. It operates or it's used in the local network only. In the local network only. Examples: ARP. ARP stands for what? The Address Resolution Protocol. IMP, which is the Internet Group. I say group means what? The multicast group. Internet Group Management Protocol. Networks. So what do I have in here? This is a network. This is a network. These are the hosts. Let's go B and C. and this is the what? This is the router. Clear? This is the router. Let's see how it works in the IGMP. Where is IGMP implemented? Where is IGMP implemented? IGMP implemented in every what? In every implemented. In every host and router in the same network. In the same network. It is part of what? It is part of TCP IP protocol. When I say it is part of the TCP IP protocol suite, it means what? You don't need to upload this protocol separately. Are you following that? It's already, when you install your network operating system, IGMP automatically get what? Automatically get installed. Because it's a part of the protocol suite. Now, let's see how it works. It is used by a multicast router. This is a multicast router to identify the host on the members of the what? Of the multicast group. To identify the members of the what? Of the multicast. Just a second. It is also used by the host to join or to leave a given multicast. So IGMP can be used for the router to figure out if there are any what? If there are any hosts here in a multicast group. It could also be used by the host to decide whether to join a group or what? To leave the group. IGMP runs over IP. What does that mean? i.e., IGMP messages encapsulated inside what? IP packets. They are encapsulated inside IP packets. They go into the payload of an IP packet. That's why we say IGMP. Notice, by the way, IGMP 3 protocol, just like the IP. It's like IP, but it runs over it. So we have this and this is the what? IGMP. But they are in layer 3, both in layer 3. But IGMP runs over what? Runs over IP, which means what? It requires the services of what? Of IP. Let's see how it works and what do I mean by here. Let's look first of all at the IGMP message. IGMP message. Messages, we have 2 types of messages in IGMP. The first message is called what? Membership query, which is general, either general or for a specific multicast. General multicast or specific multicast. What does it do? What does the router do? The router periodically send an IGMP, an ICMP message network inquiring if there are any what? Interest in joining or specific Clear? The router periodically will send a what? Will send an IGMP message. Will send a message asking the following question. Listen to the question. Is there any host interested in a multicast group? Is there any host interested in joining a multicast group? Either what? Just, in other words, I don't specify the multicast. I just what? Specify anybody interested in receiving multicast. Or I will what? I will send a what? A query telling them what? Is interested in joining a specific multicast group. Specific multicast group. If it is specific, what? I need to identify the address of the group. I need to identify the address of the group, which is what? Which is the multicast group. Clear? Okay. Now, in the message also, this is the message. Let me encapsulate it in. This one is going to be encapsulated inside the what? Inside an IP packet. You need to include the what? You need to include the version of the IGMP, the type of whether it's what? Whether it's inquiry or whether it's report. You will include what is known as a maximum response. Maximum response time means what? Means the router is putting a certain time limit to get a what? A response. Host, whether they are interested in joining a multicast or not. Checksum to check whether in the message or not, in the IGMP message, and then this multicast group address or what? If they are, if any one of them is interested in joining that multicast group address. He sent it. Will they receive it? Will they receive it? When they receive it, by the way, question. Does this one care about how many here wants to join the group? He doesn't. He wants to join the group. What is he interested in? What is the router is interested only in knowing? Is there an interest in what? In that group. Why? Because this is a same network. This is the same network and something. All of them will what? Will receive it. This is a shared network. Did you get this or not? Did you get this idea or not? He is not, the router is not interested. Us are interested in joining the multicast group. Interested in what? Is there anybody interested in joining the multicast group? Whether it's one, all what he needs to know is what? At least one is interested. Clear? So when one transmit back, the transmission back or the answer to the inquiry, the response to the inquiry is called a what? Report. A membership report. A membership report is sent by the host to either join or to leave a group. We call it a what? A membership report. Let's look at the join first. Inquiry. This one will send a what? Will send a report. Now answer me the following question. Will this one see the report? This is the same message. Work. Are you following me or not? In other words, will everyone who is interested send a report? Why? Okay. You are not getting my point here. My point here. Okay. Listen to me. Listen to me. When this one send the inquiry, to what? Is there anybody interested in joining a multicast group? Every one of them will check a certain random number. In other words, they will not answer immediately. A random number, and then what? Look at the time as it expires. By the time any one of them see a report from any one of the other hosts, send their report. Why? Why they would not send their report? They see that there is already sent a report saying that we are interested in joining this multicast group. Why do they send each report? Did you get this or not? Did you get it or not? Why are they sending a response to the inquiry? They are all interested in joining a what? One group. So if one of them says, I am interested in joining a multicast group, the others won't report anymore. Why? Because they already know that the router knows that there is an interest. This is a shared network, which means what? When this one is sending something, all of them will what? All of them will receive. Say all of them will receive it. I'm not talking about what the end users. I'm talking about what all the NIC cards will receive it. Okay. What if this one wants to leave? What if this one wants to leave? What will he send? An IGMP leave message. An IGMP leave message, which means I want to leave. Immediately, what does the router do? When he receives from a host an IGMP message saying that I want to leave the multicast group, what does the router need to do? He needs to what? He needs to send the inquiry right away. Why? To figure out, are there who wants to stay with the, because remember, in response to the inquiry, he reports one report. A reformer, he is getting one report. So when he gets a message, an IGMP leave message, he doesn't know whether there are what? Also still interested. So he sent an inquiry message again. And if there are no response to that inquiry message, it means that there are no interest in what? In joining that group anymore. What does this router do? He tells other routers, uplink, do not send me what? Do not send this multicast group anymore. There are no interest in that multicast group. Did you get me? Yes? Okay, good. So this is the IGMP message. Okay. Each membership report contains the MG address of what the single group means. Means if there is a host interested in receiving what? Two multicast group, he needs to send how many reports? Reports to the router. One report is for multicast group 1, one report is for 2. Attached router does not care which or how many hosts have joined a multicast group. It cares whether one or more of its attached hosts belong to a given multicast group. He doesn't care which one of them. All what he cares about is what? Is there an interest in my network in a receiver group? If there is an interest, then he will make what? He will make, when he receives the packet, forward it to that network, to its network. If not, then he will tell other routers, do not send me copies of this nobody interested in receiving. Each host, upon receiving the IGMP input for a random period of time, up to the maximum response time, before responding with a report. If a host report for that multicast group from another host, it will just simply what? Suppress its report means what? Don't send it. Don't send it. The router already know that there is an interest in what? In that. Clear? Okay. Now, this is how IGMP works. P is a what? Is a local protocol. That's not outside the what? Outside the network. Now, what does that mean? Remember I told you that IGMP runs over IP? In the header of the IP, you put TTL. TTL stands for what? For time to live. You put it equal to what? 1. So that when the router receives it, he decrement TTL equal to what? 0, and he does not forward it outside the network. IGMP is what? It just works on the local network itself. Does not work outside. Clear? Now, the next question that we need to answer is the following, which is the multicast routing. Okay, so this router learned interest. What does he do? This router learned that there is an interest inside the network, this multicast group. What does he need to do? He needs to tell other routers, port routers of it, that there is a what? An interest in that group. Every router needs to tell the other router, and the whole idea is to create a what? A tree. What is known as a what? As a multicast tree. A multicast tree consists of what? Links that connects to all routers that have attached belonging to the multicast group. What is a tree? When we talk about a tree, what a tree is a what? A connection of branches. Clear? A connection of branches or links. Create what is known as a multicast tree, and in this multicast tree, all the links reaches or leads to what? Routers where they have what? Interest in their what? In their network. The networks that these routers are attached. Clear? That's the purpose of the what? Automating. So, arrange for routers to deliver one copy of a packet to every subnet. Routers are what? Are attached across an arbitrary topology of routers and what? And handles issues surrounding group membership management. The goal is to find a multicast tree of links or routers that have attached hosts belonging to different or to the multicast group. So the basic concept is a what? Is a multicast tree. Let's see what type of trees do we have. We do have two types of this. One is called a source-based tree. A source-based tree is an individual tree is constructed for each sender in the multicast group. For each sender in the every sender will what? Will create, we need to create a tree, a separate tree for each sender group. Which means if there are n members, there would be what? N different routing trees construct a cast group. One for each what? One for, clear? I'll show you that in just a second. One for each sender. The second type of tree is called what? The group share tree, only a single routing tree is constructed for the entire multicast group, which means what? All the links have to be what? Bidirectional, because it's a shared tree, which means what? All the multicast group members will use this tree. So it has to be bidirectional, since the packets can flow in either direction. Let's see if you can help me with this. This is source-based. This is a source-based. First of all, we do have what? We do have the network in here. It's sending this. This one will make what? Copies. This. You end up with what? A multicast initiated at what? At A. This is the tree. If you initiate at what? If U is at A, this is the tree. If the source is at D, this is the what? Do you follow me on that? This is the tree. If the source is a tree, it's D. So he is sending this one here, this one, and this one. Clear? And so we need to have what? We need to have trees for every what? For every source. This is a source-based. Now, what do you mean by spanning tree? A spanning tree is a tree with no what? With no closed loops. Okay, so first construct a spanning tree, and the node is only along the what? Along the spanning tree. The nodes or the router is only along the what? Along the spanning tree. This one here, for example, is not part of the what? Not part of the spanning tree. So there won't be any what packet forwarded to them. The packets will only be forwarded over the links of that makes up the spanning tree. This is what? This is the multicast initiated. What? The sender is what? Is A. Whereas this one, the sender is what? B. Clear?
The time is 8 o'clock.
Is what? Oh, D. No, sorry. I'm sorry. Is D. Okay. The type of protocols that are what? That we are going to be discussing, the multicast. Some of them are what? Intra-domain. Some of them are what? Inter-domain. Just like we saw in the case, of the unicast routing. In unicast routing, we have intra-domain. Same thing in here. We have intra-domain and inter-domain. In the intra-domain, we will look at what? Several routing procedures or routing algorithms. The first one is called the multicast distance vector, which is an extension. This is an extension of the unicast distance vector protocol or algorithm. Stands for what? Distance vector. Okay. Now in here we algorithms that we will talk about. The first one is called the reverse path forwarding, reverse path broadcasting, multicasting. All of them, will be discussing them in just a second. We will also look at base tree. This is a shared. At what? At a multicast link state, MOSPF. This is an extension of what? OSPF, extension of the open shortest path first. This is a multicast link state. And then we will study what the most important, this is actually most widely used. This one, by the way, was developed in the early 80s, professor at USC. But that professor is no longer at USC. She moved to UCLA. She joined the enemy. Okay, she was in the computer science department, and she did, which is called what? Protocol independent multicast. And you will see that it is much more scalable protocols. The protocol independent multicast, PIM, and there are two types, PIM-DIM and PIM-SIM. For what? Protocol independent multicast, dense mode, protocol independent multi-mode. Dense mode when the routers in receiving multicast are clustered in a dense area. As in here, it's a what? Distributed. Sparsely means what? Means all over the place. This one here, what? Are all dense. And we will see what difference does that make when we get to this protocol shortly. All of the taxonomy for the intradomain, within the autonomous system. Multicasting within the autonomous system. That's what intradomain means. Protocol could be based on a source-based tree or a what? Or a group shared tree. The PIM, by the way, works with both a shared tree and it works with what? With a source-based tree. But the others, for example, MOM, MOSPF, DB, they are both what? Source-based tree. The core-based tree, this is core-based. Are what? Are types of what? Of group shared tree. And again, we will see each one of them. Let's start with the source-based tree, and we will look at what? Reverse. This is reverse path forwarding. Reverse path forwarding, which is this one. Reverse path forwarding. Let's see if you can help me here. Now, in a reverse path forwarding, what do we have? Is the center. Remember, this is the what? Sender base. This is this. What is he going to? What is he going to do? What is he going to do? He is going to send a copy of the. What does the router do? This router. He will make copies for this one and this one and this one. Notice, by the way, he does that there are interests in here or not. Only what is interest in here or not. Only the routers are attached to those local area network. This is another route. So he will make a copy in here. He will make a copy in here. He will make a copy in here. He will make a copy to this network. He will make a copy to here. He will make a copy to here, here, here. All of them will make what? Will make copies. So using RPF, N receives, you see N, this one N, he receives what? 2 copies of the same packet. One from this router. Is that good or not good? Then that's bad. Are you following up? But in a reverse path forwarding, it does not depend on what? On IGMP. Does not take into account any information about it. So a copy of the packet receives from the source, and a copy of the packet is what? Is a propagated. Arrows represent what? A packet is a propagated. Now, this is a reverse path. Broadcast. Excuse me. This is this one. The reverse path. See how this one works. This one send a copy. Only this one send a copy to this, because known as a what? As a parent router to this network in here. Are you following or not? But along the shortest path back to the what? Back to the host. In other words, what is the shortest path from this network, from this host to this router? The shortest path is what? Is this one rather than this one. Do you follow me or not? The packet, you make a copy only on the what? On the shortest path back to the what? Back to the host. Back to the center. And that's why we call it what? Reverse. Reverse means what? Reverse means the other way around. So when you see a router, this is a router. This is the what? This is the parent port. He will send it only to the what? When he receives it from the parent port, this one is, think about this one as what? As the parent of this one. This one is the parent of this one, Are you following or not? He will forward it, the packet, when the router receives it from the parent port, here. When he receives it from the parent port, he will forward it to what? He receives a copy. If he receives a copy from a what? He will what? He will ignore it. the packet the multicast packet needs to come from a what? A parent port, which is what? Which does pass back to the what? Back to the sender. See this one here? These are the same copy. Copy, a copy, this copy, this one, copy. This one, but does not send it to here. Why? He received it from what? He received it from a port which is not a what? Which is not a parent port. Which means what? It's not the shortest distance back to the what? Back to the sender here. Clear? Simply ignore it. And in this case, G1 will only get what? Will only get one copy of the packet. Clear? Piece of the packet. The other one, which is what? RPM, for what? Reverse path multicasting. Reverse path multicasting. Again, both of these. Both of the three. Let's see if you can follow this one here. A delivery tree that spans only subnets with multicast group members as well as routers and shortest path to the group members. Leaves or branches are going to be what? Pruned. Pruned means what? You are going to cut. Are you following me on now? Okay, I will show you that in just a second. So only what? Members or non-members branches are what? Are pruned. The packets are forwarded only along the branches leading active group members. The packets are only forwarded along the branches leading to what? Active group members, which are sent by the routers hop by hop back to the source if and only if routing messages on all its child interfaces. What does that mean? Let's assume I have a router. Okay, this is one interface, and this is this. Let's call this one R1, for example. If he receives a message, he receives a what? A leave. What does he do? What does he do? Interface. What does he do? He leave message to what? To clear? Okay, which means what? What does it mean? It means what? The route, if he receives in here, but he does not receive a leave message here, will he send a leave message up? No, because he still needs to receive the packet so that he can send it to this. Leave message means what? There is leave message is no interest. Multicast group. There is no interest in that multicast. He needs to receive a leave message for that multicast group from all its what? These are what? He needs to receive leave messages on all its child interfaces before he can forward to its upward routers. Okay, so let's see it here one more time. One more time here. These are the what? G1, G1, G1. These are interested, or these are the networks that are multicast group. So what does he do? He sends it here, here, here. Notice, by the way, no copy was made here. It's made here. Why? Because none of these are what? Interested in receiving the multicast group. Yeah, by the way, what does that mean? When this router send the what? The IGMP inquiry, into this network, there was no what? There was no report. Are you following me or not? There was this one will send what? Will send to this one a leave message telling him what? Do not send me any what? Do not send me any copy group. Clear? So he sent a what? He sent a copy to this one, a copy to this. Then why did this one, when he received it in here, why didn't he send it to here? He didn't send it to here because this is a parent port. Not a parent interface. This is a what? Back to the source. Which is the shortest distance to this? Going this way or going that way? Which means what? That is the parent what? That's the parent interface, not this one. So there won't be any what? Yeah, only this one. Did you get this or not? Otherwise, this one will receive what? 2 copies of the same packet. Send it to here. He sent it to here. This one. He sent it to here. Why is he sending it to here? He is sending to here because there is somebody in here who is interested in receiving this multicast group. To here. This one will what? Send it to here and so on. So.
We have 5 minutes.
Thank you, sir. Clear? This is the reverse path multicasting. Now let's compare it with the what? With the broadcasting that we just talked about. This one here, you notice this one? He sent it to what? And he sent it to what? To here also. Even though what? There is no interest in here. But he is going to Arriva because it's what? It's a broadcasting stuff. Clear? Reverse path multicasting, which is in a reverse path multicasting, it's what? Based on, i.e. what? Flood, prune. What does a flood and prune mean? First few packets. For the first few packets, you are going to what? To flood the network with it. To flood all the routers with it. Then what? Then the leaf routers, this is called a what? Why do I call it a leaf router? Why do I call a leaf router? Is the one that is attached to a what? To a network. Not all routers are what? So for example, if you see these are what? This one here is a network, not connected to a network. It's just connected to a host. Clear? Okay. So when a leaf router receives a multicast, and if there is no send a what? A pruning message to the what? To the router above it. Do not send me any more what? Do not send me any more copies of this multicast group, and no interest in this case here. Clear? So we call it what? Flood and what? Prune. Flood and prune. Okay. Now, let's look at the, remember by the way, all of these protocols, the algorithms that we talked about, the reverse path broadcasting, reverse path multicasting, all of them belong to what case based? Source based. Everything is based on what? On a given source. Clear? Okay. The core based tree, which is a what? Which is a shared tree. How does it work? Let's see how does it work. One node, let's say, are designated as the what? As the core. Or they call it also a what? A rendezvous node. What is the meaning of rendezvous? What? You know, some place where people gather, where people meet. Are you following me or not? They call it a rendezvous. Let's see how it works. This is based on a group shared tree concept. A center or a core node called the rendezvous node is first identified for the multicast group. Routers with belonging to the multicast group will unicast a join message addressed to the what? To the core node. And a host in here interested in receiving this multicast group send a join message to the what? To the core. Clear? To the core. A unicast, not a broadcast. A unicast message telling him that I want to what? I want to join the group. This one also. I want to join the group. Every time the join message goes through a router, the router will what? Update its forwarding table. There is a what? There is an interest, or this one became part of the tree. This message is forwarding unicast forwarding tables until it either reaches the core node or it reaches the what? The router that has already what? That already belongs to the multicast tree. That already is part of the what? Of the multicast tree. If the route of the multicast tree, he does not forward the message to the what? To the rendezvous, because the branch is already a part of the group that already belongs to the tree. The interface from which the join message is received may result in what? Concentration of the traffic near the core. The problem with by the way, all of them will receive what? All this tree. All the senders will share this tree, which means the length needs to be what? Bidirectional. But it might result in the concentration of the traffic around the what? Around the core. Most of the traffic will be going into the what? And it might create a suboptimum routes, place, and so on and so forth. All of these issues, belong to the what? When we discuss next time the PIM, we will see that the PIM starts with a core-based tree, and then it searches for source-based trees which are more optimized, which are more efficient, and then it can switch to the other So the PIM, the one that I told you was the protocol independent multicast, will start with a core-based tree, will try to change into the source-based tree according to what? According to the optimality. Okay, we'll continue this next time. Thank you.